All right, how you guys doing? It was good to talk to all of you yesterday. One of the things that a lot of you mentioned is you wanted to see more examples. So I'm going to try and do that today. So it might take us a little bit longer than usual. Feel free to fast forward if you need to, or pause it. But hopefully we can sort of talk about this. One of the biggest things you guys told me you were struggling with is figuring out which method to use and when. So hopefully we can clear that up today, and looking at these examples hopefully will help you guys out. Let me know if you still need help though afterwards. All right, so when we factor quadratics, there's 4 things that we're gonna look for. We're gonna sort of run down a checklist. The first thing you're always gonna do is look for your GCF. That's your greatest common factor. So if there's a greatest common factor, we need to take that out. Okay? If not, we just move on down the list. The next thing you're looking for is difference of perfect squares. Now, if there's a difference of perfect squares, you're usually going to know it because there's going to be 2 terms. If there's more than 2 terms, you can't have a difference of perfect squares. So we're looking for 2 terms there. And our last 2, these kind of go together, are both going to be trinomials. One is when a is equal to 1, which is going to be our x method. The other one is when there's a bigger number out front or potentially a smaller one, in which case we use slip and slide. These 2 are going to occur when there are 3 terms. So 2 terms, we're going to be looking at difference of perfect squares. 3 terms, we're going to be looking down here. But we have to remember first, we're always looking for our GCF. So let's take a look at a couple examples here. I'll sort of put these back and forth so you can look at the list. First one, 5ax minus 5a. So the first thing we want to do is we want to look for a GCF. So I'm looking here, and the first thing I notice is that both of these have a 5 in it. So I know that's going to be part of my GCF, so I am going to pull that out. And then I notice that they both have an a in it. So I'm going to pull that out. And so what I'm left with here is x minus 1. All right. Now I'm going to go down the list and see, do I have a difference of perfect squares? I do have 2 terms, and I do have a difference. However, I can't take the square root of x squared, x. It would have to be x squared. So that means there's nothing further I can do here. This is going to be my answer to this particular problem. 5a times x minus 1. I can't go any further. All right, next one I'm going to take a look at here. X squared minus 144. Again, step 1, we're looking to see if we have a GCF. There's no number that goes into 1 and 144. And I've got x squared here, but no x's here. So I have no GCF. So now I'm looking down my list, and I want to see, do I have 2 terms or do I have 3 terms? In this case, you should see I have 2 terms. And there is a difference, it's subtraction. So it's a difference of perfect squares. So we're going to take the square root of x squared, which is going to be x and x, and the square root of 144, which is 12 and 12, and I'll make 1 plus and 1 a minus. Now I am going to look at these individual things just to see if I can go any further. Okay, x plus 12, that's not a difference of perfect squares. X minus 12, also not a difference of perfect squares. I can't take the square root of either one of them. So this right here will be my final answer here. We will see some examples later on where you can keep going. So I want to point out how you want to keep looking for those things. All right, next one we're going to take a look at here. X squared minus 2x minus 63. So I'm first going to look for a GCF. Notice that's always my first step. I don't have a GCF here. There's nothing in common with x squared, negative 2x, and negative 63. So I'm moving down my list. Do I have a difference of perfect squares, meaning 2 terms? No, I have 3 terms here. So that means I'm going to be down here at either 3 or 4. This is a trinomial, and there's no number in front here. Or if there was, it would be a 1. So that's going to tell me I need to use my x method. So off to the side, I'm going to make a big X. I'm going to put the negative 63 on the top and the negative 2 down at the bottom. I'm looking for two numbers that will multiply to negative 63 and at the same time add up to negative 2. In this case, that's going to be negative 9 and positive 7. So I'm going to be left with x minus 9, x plus 7. And that's going to be my answer for this particular example. All right, so moving on to our next one. Keep following these steps. I look to see if there's a GCF. I look to see, is there anything that goes into 6, 17, and 3? Unfortunately, 3 is a prime number, and 17 is a prime number, so I'm not going to find anything that goes into them. So I look to see, do I have a difference of perfect squares, meaning I have 2 terms? Nope, I have 1, 2, 3 terms here. So now I'm going down to either step 3 or 4. This is either a trinomial where a is equal to 1, which is the x method, or when a is not equal to 1, which is going to lead me to slip and slide. In this case, you should see we have a 6 here. That means that we have to use our slip and slide method. So we're going to slip our x to our negative 3, or multiply it. So this is where I have x squared minus 17x. 6 times negative 3 is negative 18. Now, once you've done your slip and slide, then you're at that trinomial where I can do the x method. I can put negative 18 at the top and negative 17 at the bottom. I'm looking for two numbers that will multiply to negative 18, but at the same time add to negative 17. So we're going to be looking at negative 18 and positive 1. So I'm going to have x minus 18, x plus 1. Now, probably the trickiest part of slip and slide is remembering to slide this 6 back in. So I've got to divide both of these here by 6. 18 divided by 6 is going to give me 3. So this will end up being x minus 3. And 1 divided by 6, I'm not going to be able to do that, so I pop that 6 up front. That'll be 6x plus 1. That's my answer here. All right. We go through 2 more examples here for you. Maybe 3, I might have lied. All right, 8x squared minus 6x minus 5. So again, first step, looking for a GCF. I don't have a GCF with 8, 6, and 5. And this last term doesn't have an x in it, so there's no x in each term. I count my terms, 1, 2, 3 terms. That means I'm dealing with a trinomial. So that means I'm either using the x method or I'm using slip and slide. Again, 2 methods would be difference of perfect squares. Because I have an 8 here, that tells me I got to do slip and slide. So I'm going to multiply my 8 times my negative 5, and I get x squared minus 6x minus 40. Now I'm going to do the x method, putting a negative 40 on top, a negative 6 down below. So we're going to be looking for two numbers that will multiply to negative 40 and at the same time add to negative 6. In this case, we're going to be looking at negative 10 and positive 4. So this will be x minus 10, x plus 4. And I have to remember to slide back in with that 8. So both of these are going to be divided by 8 here. Now, I want to make sure I reduce these fractions 10/8 is the same as 5/4. 4/8 is the same as 1/2. And so I'm going to pop those denominators up to here. And we're going to be left with 4x minus 5 and 2x plus 1, which will end up being my answer for that one. Slip and slide is probably the most complicated method just because we got a few more steps than some of those other ones. All right, we're going to do 2 more examples here. These ones are going to involve multiple of the steps. So if we look at this one, we have 4x squared plus 8x minus 60. If you want, it might be a good idea to pause your video here and see if you can try this one on your own. Or you can just follow along with me as I go through. Step 1, I'm looking for a GCF. So I'm looking to see if there's a greatest common factor of 4, 8, and negative 60. In this case, there is a GCF. I can pull a 4 out. I can't pull an x out because there's no x in that last term. So the only thing I can pull out was a 4, which will leave me with x squared, positive 2x, and negative 15. Now, after I pull my GCF out, sometimes that's going to be it. Like the first example we did, all we could do is pull a GCF out. But you want to keep going through and see what you're left with. I'm left with 1, 2, 3 terms. So I know I'm not going to be at my difference of perfect squares, but I do have a trinomial. This is a trinomial where a is equal to 1. So from here, I don't want to just stop, but I could actually use the x method with what I'm left with inside. I put that negative 15 on the top, positive 2 at the bottom. I'm looking for 2 numbers that multiply to negative 15 and add to positive 2. In this case, we're going to have 5 and negative 3. Don't know why I put a little parentheses there, but just cross it off. So the 4 stays with us, and now I'm going to have x plus 5, x minus 3. Now at this point, there's no further I can go, so that's going to be my answer for that particular problem. Okay, so notice here I took out a GCF, then I did the x method. You'll see that's going to happen with some of these problems. All right, and this last example I think is the trickiest example that you'll see. Not overly complicated, but it kind of goes further than you might expect at first glance. So we have 16x to the 4th minus 81. I'm going to look to see if I have a GCF, as I do with all of them. There's no GCF with 16 and 81. So I'm looking down, I go down, I have 2 terms. 2 terms, so I'm going to see if I have a difference of perfect squares. See if I can take the square root of both of them. Square root of 16, I know I can do that, that's 4. Square root of x to the 4th, I can do that, that's x squared. I have the difference that I'm looking for, so I know I'm going to have plus and minus. Square root of 81, plus 9, minus 9. Now you may be tempted at this point to just circle this answer and move on to the next one. But we want to make sure we keep looking to see if we can go any further. So I'm looking and I have 2 terms again. 2 terms with 4x squared plus 9, except this has a plus on it, so I can't do anything there. So that's still just going to be 4x squared plus 9, no further for me to go. But this one, I have 2 terms, I have a difference, and I can take the square root of 4 and x squared and the square root of 9. So here I can keep going, and I can factor this one more time. The square root of 4 is 2. The square root of x squared is x. I'm going to have plus and minus, and the square root of 9 is 3. This is going to end up being my final answer. All right, hopefully these examples helped you guys out. Let me know if you still need help or not. I'd be more than happy to go through some more examples or figure out a different way that we can sort of help you out. All right.